Hello, today we're going to solve this simple problem. We are given a flat surface and a block sitting on it. And there is a friction between the block and the surface, and the force is acting on the block. So we have to find acceleration. So let's read the problem together. If the coefficient of kinetic friction between the block and the surface is 0.5, find the acceleration of the block when a 15 Newton force acts on it as shown in the figure. In order to solve this problem, we have to consider forces carefully. So the easiest way to approach this problem is break down the force, 50 Newton force, into two components. It's X and Y components. So how are we going to do it? So here is our force, which makes an angle of 37 degrees with the surface, and it will have two components. So this can be broken down into two components. One is Fy, perpendicular to the surface, and Fx along the surface. What are the other forces acting on a block if it's moving? Well, first of all, block has a weight, so weight will be acting down into the surface. Forces opposing this is a normal force acted by the surface on the block, and you have a friction force which opposes the direction of the motion, and block is moving in this direction. So what is Fx? Well, Fx from here is just F times cosine 37 degrees, and Fy is F times sine of the 37 degrees. Now let's consider the free body diagram. Along y direction we have forces Fy, normal force by the surface on the block, and opposing this, or in opposite direction, in downward direction, we have the weight of the block, which is just mg. Along the x direction we have a Fx, which is causing the block to move, and friction force F of F opposing this motion. So let's consider y direction first. So in y direction, since block is not moving in y direction, normal plus F of sub y has to be equal to the weight. From here we can find normal to be just weight minus F sub y, which is just mg minus F of sine 37, or 50 newtons minus 50 newtons times 0.6. The sine of the 37 degrees is 0.6, and this is going to be equal to 20 newtons. Now we know the normal force, so we can find a friction force, because we know the friction force is equal to coefficient of friction times the normal force. And in this case, coefficient of friction is 0.5 and the normal force is 20 newtons, so we get a 10 newton for the friction force. Now let's look at the x direction. At x direction, we have to note that the forces, opposing forces, are not equal, because block is moving and accelerating or decelerating. So we have to establish this. So first, what we're gonna do, we're gonna write down what would the net force be. Since if we assume block is moving in the right direction, then it's just gonna be F of x minus friction force, or F times cosine 37 minus friction force, or 50 newtons times 0.8, which is a cosine 37, minus 10 newtons, it will be equal to 30 newtons. Well, from the Newton's second law, we know that the net force has to be equal to the mass times acceleration, or acceleration is just net force divided by mass of the block, or 30 newtons divided by 5 kg, and we get an acceleration of 6 meters per second square. And that's all. Thank you.